Welcome to a new course in power electronics. This lecture we will discuss the introduction and the fundamentals. Let us start with the introduction of power electronics. Power electronics is a combination of three important aspects, that is the power, electric power, the components which are in the form of electronics or the electronics component, and the control technology, how we can control the power in this electronic circuit. When we talk about the power is the static and the rotating power equipment which are basically producing the power for the generation, transmission and distribution of electrical energy. So the rotating power equipment, that is the motor and the generator. But since here the generation of electrical energy we are talking about, so it will be the generator, and when the load is talking about, then we talk about the motor. So the static device means the power electronic devices will be there, which will be useful in the generation, transmission and distribution of electrical energy. The electronics are basically the solid state devices. So the solid state devices and the circuits which are responsible for connecting these devices together with the signal processing, which will be used to convert one signal to the another form to meet the desired control objectives. So this is the entire electronics part in the power electronics, where we will be using the solid state devices, and there will be some circuits which will be connecting these solid state devices, and the signal processing aspects will be there because we will be converting the signal from one form to the another, like we can convert the AC signal to DC signal or the DC to AC, or otherwise the conversion of AC signal from one frequency to another frequency. When we talk about the control, the steady state and dynamic characteristic of closed loop systems we are basically discussing, because these power which is basically controlled in order to generate and transmit the steady state conditions, and during the dynamic conditions, that characteristic has to be controlled under the closed loop conditions. Closed loop conditions means there will be a feedback path for the controlled system. Power electronics in general as defined as the application of solid state electronics for the control and conversion of electric power. So we are basically converting the power from one form to another using the electronics devices which are in the form of solid state. So that is the power electronics. Power electronics basically depends upon some switching devices which are known as the power semiconductor devices. So power semiconductor devices are responsible for the switching operation in the power electronics circuits. So power semiconductors, it improves the power handling capabilities and switching speed of the power devices tremendously. So when we are using the semiconductors, we know that semiconductors are basically used for the switching operations using the transistors, and these will obviously improve the power handling capabilities as well as the switching speed of the power devices which we are using. Now we also use the microprocessors, which has a great impact on the control strategy for the power semiconductor devices. So when we talk about the control aspect of power electronics, then that is basically taken care with the help of the microprocessors. Now, power electronics can be summed up into two important aspects, that is the power semiconductors, which are the muscles of the power electronics can be thought of, and second you have the microelectronics, which is responsible for the controlling of the power. So it is the brain of that power electronic devices. So if you see the entire aspects of any power electronic devices, you will be having the terminals such as the anode, the terminal cathode, and there is one more terminal, that is the gate. So basically you are having the three important terminals. Now here all aspects of power controlling in the solid state devices generally take place. So you will be having the electronic devices which are in the form of the circuits, and the power equipment will be there either in the form of static or rotating devices, and some control strategy will be there in the form of analog or in the form of digital. So this is the entire power electronic block, and the terminals are anode, cathode and the gate. The current direction always flows from anode to cathode. So when the current direction will flow, it will flow from anode to cathode. This gate is basically used as to control the direction of the current after certain time instant. So if you have the gate in the power electronic circuits, that is basically used to turn on or turn off the signal. So gate is basically controlling when the signal will be turned on and when the signal will be turned off. If you do not have the gate signal, means gate signal is not there and it is remaining in the off state, which is think to be the open circuit, and then it can withstand a voltage across the terminals anode to cathode. So anode to cathode, whatever the potential will be there, it will be withstand when the gate is open circuited. When we talk about the applications of power electronics devices, there are numerous applications starting from different domains, whether you can talk about the advertising, alarms, battery charger, boilers, chemical processing industries, different industries like having the conveyors, displays, electrical, dryers, electromagnetics, dissipators. So there are n number of numerous applications are there which we cannot think of if the power electronic devices are not there. So right from the low power to high power, like for example, high voltage DC transmission, that is a very high voltage transmission of electric power. And even in industries where we required to have the elevators which will be carrying very high load. So every instrument nowadays will be having the power electronic devices. When we talk about the history of power electronic devices, it generally starts from 1900 when the introduction of mercury arc rectifier was there. Until 1950s, several devices for power control was discovered, such as the metal tank rectifier, the grid control vacuum tube rectifier, the igniter, the phonotron and the thyratron. So in the year 1948, the first revolution took place, which is the invention of the silicon transistor. And this discovery was made by the Bell Telephone Laboratories by Bardeen, Breton and Sopley. The modern microelectronics evolved over the years from silicon semiconductors. So nowadays the microelectronics, as we have discussed, that it will be used to control the power, and it has evolved over the years from the silicon semiconductor. When we talk in the year 1956, the major breakthrough has taken place again in the Bell Laboratories. This was invention of PNPN triggering transistors known as the thyristors or silicon control rectifiers. So it was a major breakthrough brought about with the discovery of SCRs. Now in 1958, when we talk about the commercial thyristors was brought about by General Electric Company, and due to the fusion of this power electronics, which is the muscle with the brain, and the brain is being handled by the microelectronic devices, many potential applications of power electronics are now emerging and trend will continue. So we have seen that many applications are there where the power electronics circuits or the devices are being used. When we talk about the power electronic circuits, it has the stack and required the control of electric power as the first stage. And for this effective control of electric power, which is known as power conditioning. So power conditioning terms means the control of electric power. It is essential to convert the electric power from one form to another, because we are basically converting the signal from one form to another form. And in this conversion, you will need some power conditioning circuits. When we talk about the switching characteristic of power devices, they play a crucial role in facilitating those power conversions. So these switching characteristics are basically handled by the power switches. There will be some static power converters. Converters are basically responsible for performing the functions of power conversions. So as we convert the AC to DC signal, DC to AC or AC to AC, those are basically taken place with the help of converters. Converters are not a single device, but it is a switching matrix. So the converters can be thought of the switching matrix, and in one matrix you can thought of many switches are there, one or more switches are there, which can be turned on and connected with the supply source. The purpose is to achieve the desired output voltage. So how much output voltage you required, how much current you required, and that is basically controlled with the switching action. So these converters are not a single device, but it is the switching matrix. When we talk about the types of power electronic circuits, we can categorize it into 6 major types. First one is the diode rectifier, which is basically conversion of AC to DC. Second one is basically DC to DC converters, which are again termed as choppers. The third one, DC to AC converters, which are known as inverters. AC to DC converters, which are known as control rectifiers. Now, why the term control has been used? Because there will be some gate signal which will be controlling the AC and DC operation, turning on and turning off. So AC to AC converters, you will be having the known as the voltage controllers. They are known as the cycloconverters, and you have the static switches. So these are basically the 6 important category of the power electronics circuits. When the switching devices are used in the converters, they are employed to demonstrate the fundamental principle. So these switching devices are the semiconductor devices, which are in the form of power semiconductor devices, and the switching action within a converter may evolve in multiple devices. So as we've seen that it is a matrix form will be there in the converter. The selection of a specific devices is contingent upon the voltage, current, and the speed requirement of the converter. How much voltage you need, how much current you need, and at what speed you want to achieve the switching action. Depending upon that, you will be choosing your switching devices. Now, we will just see the brief overview of some of the operations like a diode rectifiers. And diode rectifiers, as we know, discussed that it will convert the AC voltage into a fixed DC voltage. So the input that we are giving is basically the AC supply, and whatever the output we are getting across the load register, that is in DC supply. And a diode is required for this, which will be conduct when the anode voltage is greater than cathode voltage, and it offer a very small voltage drop, ideally 0, but typically 0.7 volt. Now when you have a diode, so diode will have a terminal anode and cathode, and it is a unidirectional device, means the current will flow from anode to cathode. There will be some forward voltage drop in the diode, which is equal to 0.7 volt on an approximate. So if we supply any voltage between anode to cathode, which is more than 0.7 volt, then the current will start flowing here. This diode is the major fundamental device in the rectifiers, and it behaves as an open circuit when the cathode voltage is more than the anode voltage. If cathode voltage is more than anode voltage, then it is act as an open circuit, or it offers a very high resistance, which is typically 10 kilo ohms. So resistance will be high and it will act as open circuit. The output voltage is basically a pulsating DC. So whatever the DC you are getting at the output, it is not a refined DC supply, but rather a pulsating DC supply, which is in the form of a distorted and contains several harmonics. Now these input voltage could be either single phase or 3 phase. So whatever the input voltage we are giving, it can be either the single phase or it can be having the 3 phase supply. And the output that we are getting is basically DC. So the input AC supply is converted to output DC supply, that is known as rectifiers, and diode is the most important device for operating these rectifiers. So here you can see that a single phase AC supply is given, and this AC supply is converted to DC supply, where both the positive half and the negative half is basically converted to the pulsating DC. Now if you require a fixed DC, you will have some filters connected in the device. Next, the DC-DC converters, which are known as the choppers or the switching regulators. Here you convert the DC supply, which is the input, from one level to the output, which is at the another level of DC supply. So here one example we are taking with the help of a transistor, which is the IGBT device Q1, and it is turned on by applying a gate voltage. So when you are applying a gate voltage, gate to emitter, then the DC supply is connected to the load. So here the load is connected and a free wheeling diode is given, which we will discuss in very detail in the coming lectures. So you will be getting the output as plus Vs. So here the input is also DC and the output is also DC. So the Q1 is turned off by removing the gate emitter voltage. So using the gate, you can turn off this supply and DC supply is discontinued from the load and the output voltage will be 0. So if you require the DC voltage, then only the gate will be turned on. The average output voltage can be varied by controlling the duty cycle, which is known as delta, and controlled by varying the conduction time T1 of Q1. So the transistor IGBT, this duty cycle, which is known as the delta operation, can be controlled to have the conduction time to be different. So T is the chopping period, and here the total conduction time delta T1 is given by delta into T. Here we are giving just the brief overview. In a very detail we will be seeing in the coming lectures. So here the voltage waveform, if you see it, the gate to emitter voltage it is seen. So T1 is the conduction time. So here you have the conduction process, and the total time may be the T, which is delta, the duty cycle is given by T1 by T, and you will be getting the output voltage, which is again the DC, but here you have the output voltage Vs for a conduction period T1. And you can have the defined DC supply, which is equal to output voltages delta into Vs. So switching operations has to be there. When we talk about the DC AC converters, which are known as the inverters, so here you have the DC supply as the input, and the output which you are getting at the load end will be the AC supply. So that is known as the inverters or DC to AC converters. Here you will be having the switching devices. Here we have taken the MOSFET as the switching device. So you have M1 and M2 which are connected in the first diagonal, and the second diagonal will have M3 and M4 as the switching devices, which are the MOSFETs, and they are basically turned on by again applying some gate voltage. So here you have the gate voltage which is controlling the turn on and turn off of a particular MOSFET, and the DC supply voltage Vs appears across the load, and the instantaneous output voltage is given by plus Vs. So whatever the DC supply we are giving here using the MOSFET, which is we have taken as an example here, controlling the gate pulse, we are able to turn on. So the MOSFET 1 and MOSFET 2 are basically turned on in the first instant, and MOSFET 3 and MOSFET 4 are turned on in the second instant, and you are getting a pulse which are the DC supply. You will be the DC supply, the input you will be converting as the AC supply at the output. So first instant you will be conducting with M1 and M2 for the first DC, and then you will be having M3 and M4 conduction. So you will be getting the AC supply, and the output voltage RMS is equal to Vs, which will be getting. So these output voltage may contain the harmonics which could be filtered out before supplying to the load. So when we are giving the output voltage to the load, before that some filters has to be added so that the harmonics can be removed from the supply. The converter AC to DC is known as again the control rectifiers, because in this case only difference is that you will be having some gate pulse which will be controlling the rectifier operation. So when we talk about the diode, if you see the diode is having two terminals, that is anode and cathode. A third terminal gate is connected here so that the controlling operation can take place. So when we have the AC to DC converter in a controlled manner, then you have the gate signal. So this is the thyristor which is replacing the diode. So first we have used the diode, now we will not use the diode, rather we will be using the thyristors, and this thyristor will be having one gate signal which will be controlling the turn on and turn off operation. Again, the input will be AC, so here you will be getting giving the AC supply. This can be the single phase or it can be three phase. So either you can give a single phase supply or you can give a three phase supply as the input. The output whatever you are getting here will be the DC. Only difference before what we have discussed, AC to DC converter, which is not controlled. Here we are having a controlled operation using the gate signal. So the input whatever we are giving, here example is taken as single phase. This is being converted to the DC supply, but with a proper controlling of alpha, which is the timing instant, and this alpha is basically controlled with the help of the gate signal. So we will be getting the output with a controlled operation. When we talk about the converter AC to DC, here the supply is AC and the output you are getting a DC with the help of the thyristors. So thyristors are basically controlling it with the help of the control operation of alpha, getting the full output as the average output of the DC supply. So average output of the DC supply will depend upon cos alpha, where alpha is the duty cycle, which is basically controlled here with the help of this gate signal. So you will be getting the output voltage as DC in the case of AC to DC converter. Signal can be either single phase or three phase. AC to AC converters, which are known as a voltage controller. So AC to AC converter, you can convert from one frequency to another frequency, or you can change the level of the output voltage using some devices. So input will be AC and output will also be AC, but some power semiconductor devices will be used. Here we have used one device which is known as trike. So trike allows the current to flow in both the directions. So unlike the diode, which allows the current to flow only in one direction, the trike will allow the current to flow in both the direction. We will see these all things in very detail when the coming lectures will come, and we will see how these operations are there. Here we are giving you the overview where the AC supply, you can see here, it is the AC supply, output is also AC, but there is some controlling factor alpha, which is controlling the AC supply, how much AC do you require at the output. So that is basically controlling with the help of the trike operation, which is again the power semiconductor devices. So V0 is controlled by varying the conduction time and the firing delay angle alpha, which is of the trike. So this alpha is basically controlled with the gate signal. When we talk about the static switch, which is the sixth types of the power semiconductor devices or power electronic devices, the power devices can function as static switches, which are known as the contactors, operating either as AC or DC supply, which depend upon what type of input you are giving. The input can be AC or input can be DC. These switches are termed AC static switch or DC switches. So these are static switches. Static means stationary. So you can have either static AC input or you can have DC input, depending upon you can have AC static switch and DC static switch. The design of any power electronic equipments can be divided into four important parts. What are the parts you have? In the design of power circuit should be there. So first aspect is the power, whose design is required. Then you need some form of protection of these power devices, determination of what control strategy you required for the controlling of the power, and some logic and the gating circuits. So this is done by the help of the microprocessors and the logic and the gating circuit. So these are the four important parts when you design any power electronic equipments. Now certain symbols we used or power electronics. Now these symbols, we have a box whose in left part and right part, you can see that some signs have been given. Suppose we need to convert AC to DC, which is a rectifier operation, then AC supply is given in this form. So when you have a line with some sinusoidal signal, this is AC, and the output you are getting DC, so right part you will be having the straight line. When you have DC to DC, then you have the straight line both in the left and the right part, which is basically the chopper. Here you are converting the AC to DC. If you are converting DC to AC, then you have on the left part you are having a straight line, and on the right part you will having a sinusoidal signal present, that is the AC operation. Again, the AC to AC operation, if you see here also sinusoidal signal is there on the left part, and on the right part also you have the sinusoidal signal. So depending upon which energy conversion you are trying to achieve, based on that you will use the proper symbols, and these symbols are indication of the energy conversion. Now let us take one example of UPS. UPS stands for uninterruptible power supply. So if you see this basic circuit diagram, you have the supply, which is the mains 1 and mains 2. So two mains are there. Now the multiple conversion stage are frequently linked together to generate the intended output. So whatever the output you required, that is basically achieved by you having certain stages which are linked together. There are multiple stages. Now here, for example, if you see the mains 1, which is delivering the standard AC supply, and this is connected to the load via the static bypass. So here you can see that it is connected directly to the load. The load, you will be taking the output. The AC to DC converter charges the backup battery from mains 2. So if you have the mains 2, Here you can see one device where you are giving a sinusoidal signal in the left part. So this is basically AC. And here you have the straight line. So this is basically DC, AC to DC conversion, which is a rectifier operation. Then you have some battery operation here. Here you are having the DC to AC conversion, which is inverter operation. Then you have some transformer connected, and then you have the static bypass switch. So the supply mains 1 is connected to the load by the bypass switch, or mains 2 is also connected to the load by a bypass switch, but multiple stages of the conversion process is there, like the rectifiers, inverters, and the transformers. So this is the block diagram of uninterruptible power supply UPS using the power electronic devices. Now, the course contains what you have for the power electronics in general. The detailed one we will be discussing in very detail. But here, if we talk about the first, we will discuss the power diodes and then the switching circuits RLC networks, whether it is a combination of R, RL, LC, or RLC. So these circuits we will be discussing. We'll discuss the rectifiers, the transistors, power transistors, like for example using the MOSFET, the JFETs, or the IGBTs. We'll discuss the DC to DC converters, the choppers, the DC to AC converters known as the inverters, resonant pulse inverters, the multi-level inverters, the thyristors. How do you control the power of rectifier using thyristors, AC voltage controller, and so on. So the power electronics syllabus is quite vast. We will discuss this all in very detail, and some of the standard textbooks we are going to follow. Like for example, we are going to take the Rashid Power Electronic Devices, Circuits and Applications, the Daniel Hart Power Electronic Devices, Dr. P.S. Bhimra Power Electronic Circuit book. And we are also going to take the famous book by Ned Mohan, the Power Electronics, the Professor Umanand. We will be taking the Power Electronic Essentials and Applications, the book by Wiley Publication, Power Electronic Circuits. So these are some of the standard reference textbooks that we are going to follow for this particular course. So in the coming lectures, we are going to start with our chapter 1, which is power diodes and the RNC networks. Thank you for now. See you in the next lecture.